Hello and welcome to Learn Extra Live. I'm Katleho and this is Dina. How are you, Dina?
Well, thanks, Katleho.
Great, thank you. As it's Monday, we are doing maths. What are we doing today?
We're carrying on from where we left off last week.
Okay.
We're doing some trig, but we're looking at its application in more contextual scenarios. We're going to look at some boats at sea. We're going to look at some pilots flying. So should be
That should be exciting. Thank you, Dina. You can go over to
Thank you.
prepare your board. So, because it's Monday, we have the calculator and the Casio labeler to give away. Make sure that today, guys, our Facebook page is facebook.com/learn extra. Make sure that today that you are the most maniac, most excited, most awesome mindsetter on the page, and you can stand a chance to win these prizes. Also, you know that every week we do put the prizes up on Facebook or the prize winners up on Facebook. So you already know that people actually do win these prizes. It's not like a joke or anything, guys. We really want to give you these things. So make sure that you tell all your friends about it as well, because I can see the likes on the page are actually increasing by the day. So it's really awesome to know that you guys are with us. Our Twitter handle is @LearnExtra. And make sure that you are today's best and most favorite mindsetter with Dina. Over to you, Dina.
Thanks very much, Katleho. I thought that taking the lesson from where we left off last week, where we were solving some equations, I thought that I would start the show with a little revision of what we did last week as a challenge question. So for those of you who want to meander along your little notepad, here's the question for this afternoon. I'm going to have two of them. The first one will be now, and the next one will be after the next segment. So here's the question. If we have the equation 2 sec theta equals 5 and a condition where theta is acute, you need to work out what the value of a third sine squared theta plus cos squared theta is, but without using a calculator. So try and see if you can come up with what the value of this expression is without actually using the calculator and just using the fact that 2 sec theta equals 5 and also theta is acute. So with that information, see if you can come up with the value for that given expression. We are going to go on to the next section, which is the application of trig in a variety of contexts. Right, and the first one is to have a situation where we are given a number of triangles. I think that if you look at the picture, you'll see at least three. We've got ADB as a triangle, we've got DCB as a triangle, and we've got ACB as a triangle. And before we jump into any questions, we would like to know what kind of information is given. So if we focus on the given, we've got an angle of 50 degrees over here, we've got a side of 48, and we've got BD as a line that's perpendicular to AC, obviously therefore forming two right-angled triangles. It's important to establish where those right-angled triangles are, as trigonometry is the study of shapes, lines, and angles within a right-angled triangle. There will be scenarios where you will be given triangles where they are not right-angled, and next year in grade 11 we'll learn a little bit more of how to work out sides and angles when we don't have a right-angled triangle. For now, we are constrained by the right-angled triangle because the theory that we're using pertains only to the right-angled triangle. Right, so the question here is to find the length of AC. Now, if we look at AC's length, it's falling inside triangle ABC, and triangle ABC is an obtuse angled triangle. So straight away, I know I have a problem. I need to rebuild or reshape this whole picture so that I can be working in smaller sections, because I'm not going to be able to work out AC as standing in that triangle as it is, as it stands. I need to formulate some construction around the right-angled triangles. So if I look at it carefully, I'm able to immediately point out that we've got this triangle here that's got quite a lot of information. Firstly, it's right-angled, and secondly, it's got an angle of 50 degrees as well as a side of 48. And last week we spoke at length about our acronym, that if we are given two pieces of information, we need to be able to establish what is the trig ratio that we can utilize in order to find some information that would be useful. So in this right angle triangle, if I'm wanting to at the end find what the length of AC is, it's obvious that AD would be quite useful at this stage because it's part of that line segment AC. So if we try to work out what AD was, and we first establish my position, the position that you take is always that angle. So once you've formulated that focal point, you've established what that focal point is, the angle, you then are able to determine what trig ratio you're going to work. Without pinpointing what angle you're working in, you're not going to get to that ratio. So if I'm at B1 and I'm wanting to find that length there, what is the side, what is the name of the side AD in relation to B1? Well, the side opposite the right angle is always the hypotenuse, so 48 is the hypotenuse, which must mean that this side there is the opposite. So therefore, we've got, or we want to find the opposite side. We've also established that 48 is our hypotenuse, okay? So the trig ratio that contains both of those pieces of information is the sine. So now, since I've started off with sine of B1, that would be equal to the opposite side AD so it's AD over 48, or the opposite over the hypotenuse. So to find that, I would start off with my triangle ADB. Okay, so notice again how we wanted to find AC, but it's not in a right angle triangle, so we break it down into right angle triangles to try and work out certain portions that will eventually assist us in working out that full length. Okay, so from here, how would you solve for AD? Well, we've got this denominator that we're going to multiply on both sides, so we're going to get 48 times the sine of 50 degrees is equal to AD. And now we can use our calculator, which I haven't set up. So let's see if I can find my calculator quickly. There we go. And we want this one. Just waiting for our calculator to pop up. And while we're doing that, you can get your calculator out as well and just say 48 times sine 50.
Okay, there your calculator is.
There we go. Thank you. Right, so we've got 48 times sine of 50, and that gives us 36,770. Okay, so that's AD is equal to 36,770. Okay, so this is just this length here is 36,77. Now, if we go on to ABC or DBC, we would now have, let's use this one, got that length there. Okay, so we want to find this one. Now, what is different between the yellow and that white triangle is that in the white triangle, we had two pieces of information, one side, one angle. In this triangle here, we've only got one angle. We've only got 27. So we want to find another side, but we're missing some information. And that's the power of trigonometry, is that if we only have one angle, our next question is to ask, could we find a side? Is it possible in that diagram to find a side in that yellow triangle that would further us in getting two pieces of information? So if we go to that yellow triangle, we see, BD is a common length. So if I could find white BD, that's exactly the same as yellow BD. So it's a common side to both the white and the yellow. So I really do want to go back to the white triangle and find BD. Now let's look at BD. It is adjacent to 50, and we've got this hypotenuse here of 48. So which ratio involves my adjacent side and my hypotenuse? My adjacent side and my hypotenuse is using the cos of that angle 50, because I've already focused that that is my anchor point. Okay, so the cos, let's do this in white. So we've got the cos of 50 degrees is my adjacent BD over my hypotenuse 48. So 48 cos 50 is going to be BD. Right, and if we use our calculator for that, then we've got 48 times cos of 50, giving us 30,854. 30,854. Now, that is this length over here. This is the 30,854, that common length. We're wanting to find this yellow length there. So again, your focal point is always starting from the angle. So starting from this angle, what is the relationship of the yellow side? That would be my adjacent. What is the relationship of the side I've just found? That is my opposite. So which ratio involves adjacent and opposite? Adjacent and opposite involves tan. So tan of 27 is the opposite, which is BD over the one that I want, DC, which means that tan 27, filling in your values for BD, will give us 30,854 divided by my DC. So the question now is, how am I going to solve for DC? And it does look like this is an odd x, so let's just rewrite this and make it quite clear that this is DC. How am I going to solve for DC? DC is sitting in that denominator. Well, I'm going to multiply both sides by DC, so I get DC times tan 27 is equal to 30,854. But I still want to find DC, so I've got a product of tan 27. So now I take tan 27 and divide it on that side, on the other side, as my denominator, or as my divisor. Okay, so going back to my calculator, we've got, that's the 30,854, and I'm going to divide that by tan of 27. And so I get DC as 60,554. 60,554. Right, so let's see how far we are now. So we've been able to, within this triangle, find AD. We then wanted the yellow, but the yellow was problematic because we only had one piece of information. In order to work in trigonometry, we need two. Without two, we're not able to move forward. So we had to go and find something else. So we had to find that common side 30. Once we had the two pieces of information, we can now find the yellow one. And that yellow one we've just worked out is, what did we work it out as? 60,554. So this portion here is 60,554. In the end, it gives us a total of 36,770 plus 36.77 equals, so 97,32. So this is 97,32. Okay, so a wonderful example just show how we need to break up a complex diagram into simpler units of right-angled triangles, and working within them, contained within those various triangles, we can then work out what that total length of AC was, which originally we couldn't work out because we were not inside a right-angled triangle. Over to you, Katlego.
Thank you, Dina. So guys, we are going to go for a really quick break. This is the time for you guys to get maybe your calculators, get some refreshments. And I also just want to say thank you to Liberty as well for bringing us this awesome, awesome show. See you after the break. Welcome back, Mindsetters. If you have just joined us, we are doing maths for grade 10, and today we're continuing from last week, and that's with trigonometry. For those of you who have been here, I know that you've been having a stunning show, and I hope you keep your focus up, guys, because this is such an important show, and Trig is such an important section, and I know many of you are loving Trig, so it's good to have you here. Over to you, Dina.
Thanks, Katlego. How are you doing on that first challenge question? You've got some answers yet? Remember, you're not allowed to use your calculator, so you need to develop some technique, some tool to help you that won't use the calculator. Certainly you can touch it and work with it, but not in terms of your methodology in arriving at a solution. Well, I'm thinking that we've covered so much trig that it's time for a next challenge question before we get on to the next problem involving the application of trig. So the next question is an equation, and you are required to solve for A. And the equation is as follows: 2 cosec of 3a minus 42 degrees equals to 2,486. With this question, you may use the calculator. What is the value of a? If the equation is 2 cosec 3a minus 42 degrees equals 2,486. Have fun solving for a. Right, we're going to go on to our next problem, which is not that one, which is this one. Right, here's a story. Usually, if you're involved in some branch of mathematics, people will call on you to help them solve certain problems, and here's one such problem. We have a vertical cliff, and this vertical cliff is 235 meters. Now, somebody on top of the cliff sees, and this symbol over here is just an angle symbol, angles. So from the top of the cliff, this person sees two boats at sea, and the angles at which he sees the boats are 32 and 47 respectively. And our job is to find out how far are the boats from each other. Okay. So you kind of scan for the important information. You can visualize there's a vertical cliff, there's boats at sea, watching the boat and want to find out the distance. So in mathematics, in fact, in any problem-solving scenario that you do, you scan for the initial context to determine where you are, what it looks like, etc. Then you want to read a second time. But this time you're going to try and focus on those key words that will give you extra meaning and an extra dimension to your problem. And those are things like, why are we told about a vertical cliff? Or why are we told about a vertical height of a cliff? Is that important to us? And we're told that it's above sea level and it's 235 meters. Well, it is, because cliffs need not necessarily be vertical. So a vertical cliff basically means that something is standing perpendicular to its base. And if it's not perpendicular, we're going to get a very different diagram. So it's important to understand the mechanism of how these shapes are actually formed when we're actually drawing them. Vertical means that they are perpendicular to any base that they are standing on. Right, so vertical is very important. We're talking about something that's perpendicular. And we're also given that this cliff is obviously above sea level. Then from the top of the cliff, somebody sees two boats at sea. And then we've got these words, the angles of depression. What do we mean by angles of depression? That's a very particular mathematical terminology, and it's got a very special meaning. And it means that if somebody is watching straight ahead, that would be horizontal, that's towards the horizon. The moment you take your eyes down from the horizon and you look down, that line of sight will have changed by an arc, and that's the angle that we talk about as the angle of depression. If we've got our line of sight and we're looking up, then that angle we talk about is the angle of elevation. So we need to know where the horizontal is so we can measure an angle of depression or angle of elevation. So those are very particular mathematical terms. So we've got the angles of depression, and we want to calculate the distance between the boats. So let's try and draw this. What does this look like mathematically? So we're going to set up our cliff. There's our cliff, it's vertical. So means to the sea, it's at right angles. And this cliff is 235 meters. And somebody then stands on top of the cliff, and they look down at a ship. Okay, so here's boat A. When he looks down, and this is our line of sight, it means that he's looking down measured from a horizontal that's coming parallel to that bottom. So at the moment I'm just getting a sense. I'm not drawing anything mathematically and nothing fancy here. I'm just getting some direction as to what's happening. There's my horizontal, and my horizontal would be parallel to the sea. And when he sees that first boat, the line of sight has been measured from looking down from the horizontal. But then he sees a second boat. Okay, we're going to call that boat B. And the closer the boat is to the cliff, the bigger the angle of depression. Okay, so our job is to find how far are those boats from each other. Okay, so just to get the dimensions again, we go back and we read it again. We've got the dimensions for the vertical cliff, but we've got that the angles of depression are 32 and 47. So let's go and put those on the diagram. So this one is 32 degrees, and the closer boat to the cliff is 47 degrees. Okay, so just very roughly, two boats at sea, I'm on the cliff, I see boat A, boat B. Let's put this into some mathematical perspective. So if I was to just draw a mathematical picture, I've got something of this sort. I've got boat A over here, I've got boat B over here, I've got a horizontal that the observer is measuring the angle of depression from, of 32. I've got another boat at 47, and I've got this cliff at 235 meters. Okay, and very important, I've got that vertical cliff. So mathematics, things aren't given just because they're sitting pretty there. They've actually got some meaning, some impact. Right, so our job is to find this length here. Okay, now it's very interesting that again, notice that AB is part of this obtuse angle triangle. Can I do anything with obtuse angle triangles? No. So I've got to break my picture down into smaller units of right angle triangles. And so I'll begin with something as simple as, if this line, if the horizontal is parallel to that ground, then do you agree that B2 has got to be 47? In fact, it is true that if there's an observer and he looks down at an object, from that object, if you look up at the observer, the angle of elevation will be the same. So if I look down, somebody else looking back up to me, then the angle of elevation is 47. So these lines are parallel, the alternate angles are equal, so that's 47. And I've also got that this line is parallel to that one, so this angle of depression will equal to the angle of elevation from A. So I've got those. Now, by just filling in those two very prominent angles, we've actually created some very nice right angle triangles here that we could utilize. So what is it about this blue triangle that would help me in getting closer to AB? Well, firstly, I could find this length over here, and I'm just going to call this P. So I could find PB. At the same time, if I wanted to find out what the whole length AP is, I could work out in the green triangle I could work out what that length was. Does that help me finding that white length AB? Certainly it does. Okay, so notice how the picture started off by wanting us to find what AB's distance is. But it was impossible, so we broke it down into right angle triangles. The green one, sorry, the blue one and the green one, they're both right angle triangles in which we could find information that would ultimately be able to find what the length of AB is. Okay, right, so we've now got some calculations to do. So in the blue triangle, we've got 47 degrees is my focal point, or it's my focus, or it's where I'm at. And I would like to find out what PB is, which in relation to the angle I've chosen is my adjacent. And the 235, which is given, is my opposite. So which ratio connects opposite and adjacent? My tan ratio. So therefore, in the blue triangle, we're going to have that tan of 47 is equal to opposite, which is 235, over PB, which is what I want to find. Now again, notice if my denominator is my known, then I'm going to multiply both sides and I'm going to divide by tan 47. So I'm going to do this in two steps. PB tan 47 will equal to 235. And then if I want to isolate PB and solve for PB, I'm going to get 235 divided by tan 47. And let's get rid of this little degree here because he shouldn't be there. Okay, right, so there we are. So we can now use our calculator, and we have 235 divided by tan 47, and that gives us 219,14. So PB is 219,14. Okay, so that's this length here, 219,14. Then I've got the green length AB. So the green length is now in this big triangle. So 32, always go and find your position of the angle. I'm sitting at 32. What do I want to find? My adjacent. What have I got? My opposite. So which ratio connects adjacent and opposite? It is my tan ratio. So tan of 32 is opposite divided by AP. Again, can you see the same scenario? We have a denominator AP, so we're going to take AP to the other side, multiply by tan 32, and then we want to solve for AP, so we want to isolate AP, which is 235 divided by tan 32. So we now have, our calculator will give us 235 divided by tan 32, giving us 376,01. 376,01. Okay, so that is this length here, 376,01. Okay, so no prizes for guessing. How am I going to work out what that little leftover bit is? It's my green minus my blue. So in the end, the length I'm looking for is my 376,01 minus 219,14. So the distance between the ships minus 219.14 is now 156,94. So 156,94. And I think it was in meters because the vertical cliff was 235 meters. So There we go. We've been able to, what we've done mathematically is what we call modeling. We've modeled what was in words into a mathematical diagram, and we've been able to use trigonometry to help us to find the length between those ships.
Thank you, Dina. So guys, we are going to go for a really quick break. Get refreshed, get revitalized, but do it right on your seats. Do not move, because we are back with some more interesting trigonometry. See you now. Welcome back, Mindsetters, to the Maths Show for Grade 10s today. Grade 10s, I hope you've been having such a great time. We've had some very nice, interesting trig sections. So just make sure that you have jotted down this question, because it's very nice for you to go through the question later when your mind is, nice and calm, and you can practice it and everything else. Keep writing your notes as well. I mean, they will help you later on, guys, I promise you. Over to you, Dina.
Thanks, Katlego. I'm hoping that some of you by now would have really gotten that answer to the challenge, the first challenge question that we posted at the beginning of the show. So let's quickly have a look at how you've done. And hopefully you'll be bouncing up and down wherever you're sitting if you got it right. And if you didn't get it right, well, this is what Learn Extra is all about. It's so that you can learn a little bit extra and be a little bit more prepared for that final examination, which is coming up just around the corner. So let's get to that first challenge question. We had, if 2 sec theta is equal to 5 and theta is acute, calculate the value of that expression without a calculator. So our focal points are the fact that theta is acute, so therefore I can work in a right angle triangle. And we've also got the ratio 2 sec theta equals 5, which will help us in going a long way. So we would have sec theta equals to 5 over 2, which would automatically give us that cos theta is equal to 2/5, because we know that cos theta times sec theta equals 1, since they are reciprocal ratios. So it's much easier to work with a ratio that we often use with SOHCAHTOA. We often take sine, cos, and tan to find out angles. Much easier, that's what's on a calculator. So we try and reduce things into formats that we're more comfortable with, really. Right, so if theta is acute, we've been told that theta is acute. We now have that, this is the scenario. There's my theta, it's right angle triangle, and we've got that cos theta is equal to 2/5, and cos is adjacent over hypotenuse, which automatically helps us because we can now find out what the third length is without a calculator. We're not meant to find theta. You could have worked out what theta was just to compare your answers, but how would we find out this length in the right angle triangle? Yes, Pythagoras is always around to help us. The hypotenuse would be 25. This would be 4, so this would be the square root of 21. Okay, and that automatically means we've got what a third of root 21 over 5 squared is, plus cos theta, which we've also got from here, 2/5 squared. Okay, so sine is opposite. This is opposite over hypotenuse, and this one is adjacent over hypotenuse. So my opposite of theta is to root 21, and my hypotenuse is 5. So if I now just keep going, I get a third of 21 over 25 plus 4 over 25. So my common denominator is 3 times 25, so this one is just 21 plus 3 fours are 12. And we get 33 over 75. So without finding the angle, I've been able to find out what an expression is by utilizing the trig definitions from a right angle triangle from the SOHCAHTOA. So I'm wondering how many of you are really thrilled that you got 33 out of 75. That's good going. I'll do the second challenge question once we've looked at one of our trig contextual problems. Right, and the problem is as follows. Okay, this time we have a pilot. And the pilot, he's flying at 2,500 meters, and he reads the angle of depression of the top of a 60-meter building directly ahead of him as 22 degrees. So remember, all you're wanting to do is to get your bearings, to get the feel for what is going on here. Here's this pilot, he's flying, and ahead of him, he sees the top of a building. So he's flying on the horizontal, parallel to the ground, and we're making those assumptions here. And he then looks at the top of the building. So from the pilot's view, he's going to have to look down at the top of the building. So that creates that angle of depression. So remember, you're wanting to be able to capture this information in a different format, in a mathematical format that will assist you in solving for these unknowns. So just to give you a feel, here's the pilot. He's flying at 2,500 meters. He then sees the building, and there's the horizontal, and he looks down at the building. And they tell us that the angle of depression of the top of the building is 60 meters. Okay. So as a smart student, and this is not just in mathematics, but all across the other subjects, whether we're English or geography or any of the sciences, you need to always go back and read for meaning. You're not just reading just that there are words going through your head, but you're wanting to extract as much meaning as possible. So the first thing is the pilot's flying 2,500 meters. We are assuming that that pilot is flying parallel to the ground. And so we're making some assumptions here that this is vertical. Okay? There's a 60-meter building. So your automatic thinking is, well, if this plane had to fly across, how much would that be? Okay, so you begin to ask questions that would also extract some kind of meaning. Right, so we read again to make sure we've got all the information. A pilot flying at 2.5 reads the angle of depression of the top of a 60-meter building directly ahead of him as 22. So from the horizon, he's reading that as 22 degrees. Okay. And further than that, there's not much we can draw there. It just says, how far must he fly to reach a position directly above the building? So what is it actually saying? How far must we go, or how far must the pilot go, so that he reaches a position, so that he reaches that position? And let's call that position B. Okay, so we're really looking, how far is AB if we've got all this information? Well, we really do need our right-angled triangles. Without right-angled triangles, it's impossible to work out any lengths. So let's see if we can make up some right-angled triangles over here. We've got this position above the building, which is going to be a right angle. And we really do want to know how much this is. So I'm going to give these things some labels. AB, let's give this one C. So the building is CD, and AE is how far the pilot started off with at that position there. And obviously you're capturing, these are snapshots of just moments in time, because we can't capture the dynamic nature of this plane flying. So at that one position, this is what we see. We want to know what is happening once the plane has flown all the way to B. And can you see that, again, we've only got 22 degrees. Only one piece of information. How many pieces of information do we need with trig? We need 2. So we really do need to know how much that is. Well, that's not difficult to find, because the distance that the plane was flying, if he travels all the way across and he's not, we're assuming he's flying at 2.5 all the way, then this length over here is indeed just going to be 2.440. Okay, to give us that whole total of 2.550. So now this becomes quite interesting, because we now have this right-angled triangle over here, and we would like to find, if we position ourselves at this angle 22, that's my adjacent and that's my opposite, because this is my hypotenuse. So we would create the trig ratio that involves opposite and adjacent, which in this case is going to be our tan. So our tan of 22 degrees is going to equal our opposite, which is 2440, divided by that AB that we're looking for. Right, by now we're professionals. We know how to find the denominator when we have the trig ratio and the denominator is the unknown. We've seen that all that happens is AB gets multiplied that side, and then we're dividing that by tan 22. So in the end, we can now use our calculator to just see what 2440 divided by tan 22 is all about. That gives us a distance of 6,039 meters. So that's 6,039 meters. Okay. So we're saying that if the pilot flies 6,039 meters, he will now be at a position which is directly above that building of 60 meters. Okay. Now, there's a further question to this. There's a follow-up question. It then goes on to say, what is the angle of elevation of the aircraft? Okay, so these words are quite powerful because they tell us what we're looking at. So we are looking at the aircraft. Now, from where are we? From a point on the ground directly below his first position. So where's that? Where is the position on the ground which is directly below the pilot's first position? Do you know where that is? Let's go back to the picture. Okay. On the ground, the first position would have been at position E. And so we've now got that we're looking at the aircraft's new position. Its new position is at 6,039 meters. And so we would like to know what that angle is because we are elevating, so we are looking up. So that's angle E1. So what is that angle of elevation? And you see how you've translated that English into an actual model of what it looks like in mathematics. And that is what mathematicians do all the time. They take context and they try and adapt it into a mathematical context so that then they can use the mathematical tools to help them solve these problems. Right, so the pilot's first position was at A, position directly below him would be at E, and now we are looking at B and we're getting that angle of elevation. So we've now created this new right angle triangle. It's all about finding the correct right angle triangle. And building is at 90 degrees, and we would like to find out how much this angle is. Well, any suggestions? We've only got one piece of information. We've got that as 25. But the pilot has just flown 6,000. So if that was 6,039, that must be 6,039. Okay? So now we have two pieces of information. And with that, we can find angle E1, because if we at the angle E1, this length is opposite, this length is adjacent, so we can use the tan ratio. So we've got the tan of E1 would be equal to the opposite over the adjacent, and E1 is now going to be an angle that we are solving for. So on our calculator, we're going to have a button, a special button that finds us the angle, which is that tan to the minus 1. So we're going to first press the function, and then we need 2500 over 6039, and we just want to get out of that. And what is the angle? Well, 22,5. So it is almost the same as the angle of depression earlier, just half a degree. If somebody's looking up at the plane, they can actually see it at 22,5. And how many times haven't you been on the ground and looked up at a plane? So every time you've got a line of sight to the plane, that's actually your angle of elevation. So the next time you look up at a plane, just ask yourself, how many degrees do I think that this angle of elevation is? But remember, somebody in the plane looking down at you will be asking a different question. They'll be asking, what is the angle of depression of the person on the ground, if they can see you, that is. Okay, so there's a nice question that involved both angle of depression and an angle of elevation. All right, I think it's time now to go back and do that second challenge question on solving that equation and see how many of you were actually able to get that angle A. Right, and some of you are saying, but I've got angle A, I've checked my answer, I know it's correct, I would like another little challenge. So maybe we'll do one that we haven't done, and we'll check this question in a moment. We've got the shadow of a tower, 91 meters high, is 63 meters long. Calculate the angle of elevation of the sun. So I'll leave you to ponder on that one for a little while. You can get working. There's a tower 91 meters high, it casts a shadow of 63 meters. What is the angle of elevation of the sun? Okay? And while you're busy with that, the rest of us will be doing the challenge question, what is the value of A? Okay. Very interesting is that with this equation, we're sitting with that cosec, and we know that the calculator only has angle buttons for sine, cos, and tan. So our job is to, first of all, rewrite this equation in a different format, meaning the same, but in a different format. So we've got, first things first, and is that coefficient. We eliminate the coefficient, and we keep this angle as is, 2,486 divided by 2, which gives us a ratio of 1,243. Okay? Now we have a cosec ratio. Who is the reciprocal of cosec? It is sine. So if I take the reciprocal of cosec, which is sine, then I'm going to take the reciprocal on that side, which is 1 over 1,243. And that's how I get around my cosec, sec, and cot, is I use their reciprocal ratios by taking the reciprocal on the left and the reciprocal on the right. Once you've isolated the trig ratio, you're now ready to use the calculator. So we're wanting to know, it's a sine function, so it's sine to the minus 1, and it is 1 over 1.243, and that equals to 53,56. Okay, so 53,56. So therefore, our angle of 3A minus 42 degrees, what was it again? 53,56. 53,56. And we can now solve the equation 3A equals to 53,56 plus 42, and then we can solve for A by dividing that by 3. So it's 53,56 plus 42 divided by 3. And that gives us A. So let's see how many of you got that right. Let's just move that across. So we've got 53 plus our 42. And we're going to divide that by 3. So we get 31,9. And because there was no instruction, okay, you can then just write it off to one decimal place. So how many of you are jumping up and down that you got 31,9? How many of you checked your answer? It's very important with an equation to test the answer. So you would have come here and you have said 3 times 31 minus 42. You would have taken the cosec times 2 and you would have seen, did you get to 486? Because that's really the answer to the question. Okay, so we won't do that. We'll leave you that to do. Let's go back to the angle of elevation. See how many of you have been able to get that angle of elevation. What is the saying? The saying that if there's a tower and it's 91 meters high, it's going to be casting a shadow of 63 meters. And we're wanting to know what is the angle of elevation of the sun, which means we're looking up at the sun because the sun is casting a shadow on top of the tower. So we'd like to know what is this theta. And that theta really is the side that's opposite and the side that's adjacent, which is the tan ratio. So tan theta is equal to 91 over 63. And let's see what our friend, the calculator, says about that. So we've got tan of 91 over 63. And let's see what that angle of elevation of the sun is. And it was 55,3. So theta equals 55,3. Right, hope you all had fun. Bye.
Thank you, Dina. So guys, as you know, you went through a lot of trigonometric math today, and it's been absolutely awesome. Thank you for joining us. Thank you to Liberty again, and thank you to you Mindsetters for actually making the show. I know it's Monday and it's one of those days, but it's a warm day, and you guys joined us today, and we are grateful for that. There are still some prizes, so remember, you can still continue on the page while the grade 11s are on the show. See you guys. Bye.